Welcome to this lesson on evaluating integrals using substitution. Today, we are going to evaluate the integral of 3 to the power of x divided by e to the power of x dx. Our goal is to find the antiderivative of this expression using substitution. Before performing substitution, let's simplify the integrand. Remember, exponents can be rewritten using properties of powers. So, 3 to the power of x divided by e to the power of x can be expressed as the fraction 3 over e whole raised to the power of x. Now that we have a simpler expression, let's move on to substitution. We can use a variable substitution to make the integration straightforward. Let's set u equal to the fraction 3 over e raised to the power of x. Then the expression can be rewritten as the integral of u with respect to x. Next, we need to find the differential due. Let's differentiate u with respect to x. Note that the derivative of a to the power of x is a to the power of x times the natural logarithm of a. Rearranging for dx in terms of due, we obtain dx equals due divided by the natural logarithm of the fraction 3 over e times u. Let's substitute back into our integral. This presents us with a more manageable integral. The integral of due over u divided by the natural logarithm of 3 over e. We can factor out the constants, giving us 1 over the natural logarithm of 3 over e times the integral of due over u. The integral of due over u is a standard integral, which evaluates to the natural logarithm of the absolute value of u plus a constant of integration c. Substituting back for u, we obtain our final antiderivative result. In conclusion, through substitution method, we have derived that the integral of 3 to the power of x divided by e to the power of x dx equals 1 over the natural logarithm of 3 divided by e times the natural logarithm of the absolute value of 3 divided by e raised to the power of x plus a constant of integration c. Substitution is a powerful technique in finding integrals that might initially seem complex. Thank you for watching.